Hi, this is Dr. S and this is video 8 in my series on reaction rates for Year 13 A-Level Chemistry. In the previous video we looked at initial rates methods and how that would be used to obtain a rate concentration graph. We obtained a rate concentration graph that looked like this, with a straight line, a directly proportional relationship between concentration and rate. Now that is specifically for a first order reagent. So if we have a first order reagent, we know already that rate is proportional to concentration, and the rate equation would look something like rate equals K concentration of A. We'll just use A for now, we won't use any other reagent. That would be an example of a rate equation that would give this sort of graph. Now I alluded in my last video to the fact that it's not the same for zero and second orders. So let's look at how zero and second orders behave. Well, let's think about a zero order. A zero order reagent, there is no link between the rate and the concentration. So in the case where there would just be A reacting, the rate would actually just be equal to K, and the concentration is not even involved in the rate equation. The result on the graph is that you would then have a horizontal line, because even if you cranked the concentration up to a very high level, the rate would still be the same. So that is zero order. That's first. Okay, what about second? So for second order, we know that the rate is proportional to concentration squared. And in terms of a rate equation, rate equals K concentration of A squared. So how that would look on the graph is you would get an exponential curve. Y equals X squared. So it looks something like this. So if you are given a rate concentration graph, you should be able to then determine which order reagent it is from the shape of the graph. If it's horizontal, it's zero. If it's directly proportional, it's first. If it's exponential, it's second. Okay, now what you can do as well is you can use these graphs to actually calculate the rate constant. So if you look at the zero order, rate equals K. Well, we know the rate here, and it's always level. So actually in this case, the y-intercept there would actually be equal to K. So for zero orders, the value of K is the value on the y-intercept. If you look at first order, rate equals K times the concentration. Well, actually the first order reagent here is a gradient. So if you divide the gradient by concentration like this, you actually get the value of K. So for a first order, the value of K is the gradient of the line. Now you can't actually determine the value of the rate constant for a second order reagent from this graph. But what you can do is draw another graph that allows you to do that. If it's a second order, what you can do is plot rate against concentration squared, like this. And that will give you a straight line. That straight line, if you take the gradient of that, would be the rate constant. So for second order, it's the gradient of line on a rate concentration squared graph. Okay, so after this video you should be able to identify the order of reaction with respect to any particular reagent by looking at a rate concentration graph, and also explain how to calculate the rate constant from each type of graph. In the next video, I'll look at how to use experimental data to calculate the order of reaction, which is a very common exam question. I'll see you then.